So, hi, thanks for coming. Thank you for inviting me, Joe. It's a real pleasure to be here. I'm having a great time. I'm a little hopped up on Sudafed, and I'm already pretty energetic, so I seem overly energetic. INKITS is Intelligent Tutoring System for Inquiry. That's what it stands for, INKITS. And our teacher dashboard is called InkBlotter. And we're really excited about this work because it really has moved the needle for students and really moved the needle for teachers. And this is really my first foray into building stuff for teachers with InkBlotter. I've been building, software for students for a long time. I came from Toronto, University of Toronto, with Carl Bereiter and Marlene Scardamelia, who developed Cecil. Now it's called Knowledge Forum. So that was pre-internet. So I'm dating myself a little bit, but that goes to show kind of how long and how far we've come in terms of technology for thinking. And a lot of those pedagogies that are underlying things like Knowledge Forum, or Cecil, getting students to think intentionally, getting students to develop higher level reasoning and higher level epistemological frames for thinking, has really been the goal of many of these tech platforms that people like Joe and myself and others have developed. And these are the kinds of things that should be productized. So this is my roundabout way to tell you that INKITS is being productized by a company called Apprentice, which is the verb from apprendre, to learn. So I speak French, sort of. My French is not great, but in many languages, apprentice stands for learning. So my point here is that the US government, starting with the Bayh-Dole Act in 1982, really wanted a return on investment from government grants to university professors, and they wanted things to be productized. So this is sort of of that ilk as well. The US Department of Education was very interested in us productizing this, and so we decided to do it. And the reason that one productizes something is that you can sustain it over long periods of time, because otherwise, for example, when the project ends or the funding dries up, teachers log on in August and guess what, it's gone. And this could be a platform they've used for 5, 10, 15 years or something. All of a sudden it's gone. And the government doesn't want that to happen. So SBIR grants were designed to help productize so that products could be sustainable and they could be offered at lesser price to larger amounts of people. So that's been our goal as well. So we have a footprint in 50 states. And we actually have a footprint in 57 countries, although some is just a handful of teachers here and there. So we're really happy with our traction, and we're really happy to get this into the hands of many teachers and students. So on that note, thank you for coming. It's a pleasure to be here. So again, I'm talking about INKITS. This is AI-based technology for real-time assessment, scaffolding, and instruction of science practices. And I'm the founding CEO of Apprentice, which is productizing INKITS. So, next. So what I'm going to talk about today is the context of the problem. This is a problem we all know about. I'm going to tell you a little bit about the goal and give an intro to INKITS and InkBlotter. I'm going to talk a little bit about evidence-centered design and our development process. Then I'm going to kind of overview 4 fire hose studies that give you a sense of the breadth of the research on the student end and on the teacher end that we do. And then I want to have a conversation about formative assessment. And I say a conversation because I recognize who's in the room. I recognize the strength in formative assessment here at MSU, probably the strongest place for formative assessment. So I'm very flattered and to come and talk to you here about INKITS for formative assessment. So the context of the problem is that the US and many other countries face a STEM crisis. So we're now 18th. We used to be 13th. We were 25th. I mean, we've bounced around, but we're 18th. Canada, where I'm from, is 7th. Just draw your own conclusions. No, I'm kidding about that. But we're always 7th. Canada's 7th. It's like, that's what we paid for, I guess. We got locked in at 7. But what this performance has led to, and the United States really has played a pivotal role in the frameworks, the 21st century skill frameworks, because the rest of the world really follows, I think, to a certain extent what we do. So the 21st century skill frameworks and state frameworks, including the NGSS, seek to improve students' competencies at science, right? This requires that students learn all these practices. All of you know all these practices really well. But also requires that teachers assess and provide instruction on these things. Okay, so the former, the student learning of these things, is difficult. No questions asked. The assessment of these things and the instruction of these things is not a trivial problem. And doing it at scale is not a trivial problem. And doing it rigorously so that teachers have actionable data is not a trivial problem. So that's where I've spent the last 15 years, is working on this pre-NGSS. And I'm going to tell you more about this today. So here's a classroom. All these kids are working perhaps even on different science experiments or testing different hypotheses, right? So here's, I call this kid Billy. This is just a stock photo, by the way. Billy's a science genius, and he can do all this science. He's really good at the doing of science, but he actually is not very good at communicating what he knows in words. A lot of really high-level STEM kids are kind of like that. Conversely, here's Johnny. Johnny's not even doing the experiment, right? And Johnny could be a kind of kid who can parrot what he's read or heard, but he's not good at doing the science. In fact, he's not even doing the experiment, right? So we have shown, and others I believe will concur, that if you rely on what students write, and I think Alicia Alonso wrote about this as well in her work on formative assessment, and so did Berland and McNeil, if you rely on what kids write, you're not necessarily going to get at all their competencies. Well, that makes perfect sense, because think of the wide range of competencies that we expect kids to learn in NGSS. And some kids, like ELLs, for example, kids who are not good with writing, STEM, people that are high level in STEM are not necessarily good at writing. So we have shown that if teachers rely on what kids write, they are misassessed with respect to the practices between 30 to 60% of the time. So that's not a trivial error band there, 30 to 60% of the time. So I wrote about this in US News and World Report a while ago. So what we wanted to assess science practices rigorously at a fine-grained level, and this means subcomponents underlying each practice. So these aren't like learning progressions. They're not learning performances either. They're even a level below that, these actionable little subcomponents, right? And then assess these at scale. That was our job. That's what we took on. And we wanted to better support teachers in their instruction of science practices at an actionable level, right? There's been a lot of talk about learning progressions not being actionable for teachers. And in their assessment of science practices at a fine-grained level to support students on the full competency, the full range of competencies, and also for students with longer learning trajectories, like those who are on IEPs, etc. So I'm also trained as a school psychologist with an area of focus on assessment. And you meet kids who are so good at certain things and not good at other things, right? And our educational system is really not good at assessing students in that way. And we tend to take as ground truth what people say and write as what they know. But think of all the competencies, STEM in particular, that are not well assessed via words. And then lastly, we wanted to support students in their learning of science practices so that these will transfer to new topics as envisioned in the NGSS. Okay, so that was our charge. So we developed INKITs. An overview is these are simulation-based assessments. There's 157 of these and counting for science grades 4 through 10 to assess the practices, and we use the assessment triangle and evidence-centered design. These include content variables based on students' misconceptions and difficulties with the practices. And these were built, piloted, and refined with think-alouds with individual students and teachers. And we actually started with a physical ramp apparatus, and I have a book chapter on this. We had a ramp apparatus and kids would roll the ball, different balls down, and they would measure the texture of the ball compared to the texture of the ball, all these variables. And we watched how they did it, and we had them thinking aloud. That's how we started. And then we storyboarded, and then we put it into tech, and then we tested kids. And we had this great after-school program in Worcester called Friendly House. And kids, some of whom were homeless actually and lived at Friendly House, would come to our lab once a week. And we had about 12 kids, because they had a bus that had 12 seats. So 12 kids would come. Conveniently, my group was about 12 people at the time, so we would work with them one-on-one and record everything they said. And it was really a wonderful time. Kids learned a lot. So we have simulations, widgets, and tools that capture students' interactions and inputs. So think about it. Every mouse click, every time on task, every selection within a widget, every change to the simulation. So these log files are, hundreds and hundreds of pages. And then we build performance assessments, reports, scaffolds, alerts, and now tips for teachers on students' inquiry practices and the skills that are generated. So this required operationalizing these practices into respective sub-skills or sub-components. Okay, that's what you have to do if you're going to build an intelligent tutoring system. So we use machine learning, we use knowledge engineering, and we use natural language processing. And these are used to assess and scaffold students' practices and alert teachers as to who needs help, why they need help, how to help them. So here's a full, sort of a full cycle. You have a student working in inputs. You have every mouse click, everything's being tracked. The algorithms distill everything up. We have real-time reports and alerts and tips being generated in real time. So the teacher can walk around the class with a dashboard and say, 80% of your kids are changing too many variables at once, stop the class. Or go help Susie, or whatever. I'll show you that a little bit more. And then you have Rex jumping in real time if the teacher wants to run with Rex. So Rex is also giving actionable level detail to the student on how they need to improve their inquiry performance. Now, kids sometimes complain about Rex. So we had teachers saying, kids don't like Rex. And I said, well, which kids are complaining? And she goes, it's the kids who really are used to that bottom-out hint that tells them exactly what to do. So I said, tell them that Rex is there to help them. And if they do what Rex says, they're going to get better and Rex won't show up. And there was the magic pill, right? Kids are like, yeah, I hate this dinosaur. Oh, I'll do what he said. It's like as though the software is designed to teach them something. Go figure. So this is sort of how the system works, and then I'm going to break it down in pieces. So we use evidence-centered design. I know that you folks know about evidence-centered design. I think it's really a fantastic way to think about assessment development, and if you don't use evidence-centered design, what ends up happening is you want to assess all these things, and the system is not designed to elicit them. The system has to be designed from a UX perspective, and the tools that you use, the widgets, etc., have to be designed to get that information, right? So you see a lot of simulations. Simulations are a dime a dozen, but you can't use them for assessment if they're not instrumented and designed for assessment. So we use evidence-centered design to specify what are the features we're going to use. And Bob has written really nicely, Bob Mislevy, logic models. And I think these logic models are absolutely fantastic to think about the relationship between the learning materials, the assessment materials, and then the performances you're trying to elicit. And it's been used for evidence-centered design. We also have a chapter with Bob, this Mislevy et al. 2020 in a book that we unpack this in a lot of detail. So let me talk a little bit about this. The first corner is cognition. And I wrote a chapter, I think it's the Zhao Ning chapter actually, where I'm talking about this, or I'm unpacking each part of the triangle in lots of detail. And so all assessments, right, are based on an underlying theoretical framework about how people learn, right? So this is not a profound idea, but it's necessary then to think about, okay, tacitly there's something in there, but how do you then elicit? So we have to specify or operationalize the knowledge and the cognitive processes underlying the targeted performances. So Jim Pellegrino talks about this really nicely. And this includes both observable processes and those that are proposed to be happening, right? Because of course this is cognition, and a lot is happening that is not tractable to technology, right? And is sometimes not even tractable to the user. They're doing a lot of things that are tacit knowledge that, that we're not noticing. So you need a system that will pull those things out as much as possible. The second corner is observation. And these are the ways by which a student's knowledge or competencies are observed for a target conception or a skill or a practice. And the key to doing this, again, is to elicit the item. And the tasks must elicit a broad range of competencies because that's the goal of assessment, right? And this is where that messy middle comes in. Because, you know, it's easy, in quotes, to assess a student who doesn't know very much. It's also kind of easy to assess a student who knows a lot. But those students in the middle, the messy middle, and what we have to do is be able to assess their partial competencies and their partial knowledge and how it's developing. So you need this at the sub-practice level or the component level, which is what we've done. And then the interpretation corner, right? So this is, you know, this is where researchers, this is like catnip to us, right? We love this, is specifying the internal cognitive states. And these are elicited by these tasks and items, right? And it's critical that you attend to this beforehand, because otherwise you're going to end up with all these data that you can't analyze, and a system that's not instrumented to get, you know, to get this information, right? All right, so INKITS targets these known difficulties with inquiry. Some of these I don't need to tell you folks, but identifying variables to target and observe, conducting controlled experiments. Even adults don't know how to do that if we don't train them, so Deanna Kuhn has shown that. Using data to determine relationships between variables, doing mathematics associated with science inquiry. This is where a lot of high schoolers kind of fall down. They don't have the math competency to support the science understanding in high school. And then using and explaining data, evidence and reasoning while communicating results. I talked a little about those Billies and Johnnies. And linking data with explanations. So if a system's too open-ended, right, teachers spend considerable time trying to scaffold students. Well, this is near impossible, right? And imagine the expectations for NGSS where a teacher has to run over, has to look at the screen, has to figure out what's going on in the mind of the student, and then give them actionable advice, right? I mean, that is just an unbelievable thing to actually require for teachers to do. So giving them data at the actionable level, the data they need, allows them to move forward and move the class forward and move individual students forward in a very productive way. So INKITS assesses, scaffolds, and alerts on students' question formation competency. So you have all these troubles, right, that kids have. Forming testable hypotheses, choosing which variables to work with, may not know what a hypothesis should look like, avoid stating hypotheses that could be rejected. We assess, scaffold, and alert their competencies at designing controlled experiments, so they may not test their experiment, they may not gather sufficient evidence, they may change too many variables in the same trial, that's classic. They may run experiments that are enjoyable to watch instead of testing their hypothesis. This happens all the time. For data interpretation, they draw conclusions based on confounded data, they change ideas about causality, they don't relate outcomes to the theories being tested, that's that reasoning piece. They make claims about data they didn't collect. This is classic too. That's like that Johnny, right? We have data like this, I'm going to show you.
Classic album.
Yeah, exactly. And may engage in confirmation bias during inquiry. Kids do this all the time. State conclusions that don't align with their experimental findings despite having observed something. Then with regard to argumentation, they use inappropriate and insufficient data in providing reasoning for their claims. They have trouble linking their data to their hypotheses. They rely on theoretical arguments rather than experimental evidence. And then with regard to our newest stuff, we have an IES grant, myself and Mike Salpedro. With regard to constructing graphs, they have difficulties determining axes, determining what data to include in graphs, understanding the relationship between variables in data tables and graphs. determining the type of functional relationships, linear, curvilinear, etc., the components of equations, applying best fit lines. So a lot of these are built into that mathematizing practice, modeling and mathematizing, but that's a particularly fuzzy strand of the NGSS. So partly what we're doing is operationalizing that. So we are assessing scaffolding and alerting on students' mathematical competencies. So these are an example, including their claim evidence reasoning, how they're using their mathematical data to substantiate their claim. All right, so with virtual simulations, this permits authentic science inquiry learning and assessment because they share many perceptual features. So I love Don Norman's statement, right? Like they have these affordances. And an affordance in Norman's terms, different from Gibson's terms. So Gibson was like an affordance is a thing that's a property of the object. But then Don Norman came along and he said it's not a property of the object, it's only a property if the student knows what to do, right? Then that's an affordance. So I love Don Norman's interpretation or definition of an affordance. So with simulations, kids can develop a hypothesis, they can use models, they can analyze data, warrant claims, construct explanations, and argue from evidence. They can. These are affordances of these things, but they have to be oriented towards doing it. They're not naturally going to do it. They're not going to naturally discover. I mean, maybe some kids do. The kids I've worked with my whole life don't naturally discover many things. I mean, some of them do, but so that's why you need scaffolding, and that's why you need assessment so you can trigger scaffolds in a fine-grained way. So what are the benefits of virtual simulations for cognition, observation, interpretation, and instruction? And this is what I'm writing for this book chapter. So you have the affordances of authenticity. This is greater than multiple choice tests. But these systems are not currently being used to assess the skills they were designed to foster. So that's just a lost opportunity. And we have the technology to do it, so why aren't we doing it, right? They generate rich, high-fidelity log files used for performance assessment. The work products and inquiry processes can be scored, scored in real time. And they can give immediate feedback, blending learning and assessment. So extra assessment time's not used, so it's stealth. And they could replace summative tests. And you know, PISA, for example, is moving in that direction. I'm on the AI panel for the PISA. And there's definitely a move towards AI-based performance assessment. So, but you know, there are challenges to inquiry assessment as well. So I don't want to be naive about that. So complex tasks take longer. There's more than one way to conduct inquiry. Subtasks are not independent. Traditional measurement methods are difficult to apply. And most importantly, and I think where we did some nice work, is you need a theory to distill and aggregate all these log data into design categories a priori, which is critical to the interpretation, so that the results are pedagogically meaningful to teachers and students, to the right stakeholders, right? Because if you're, you know, it's not just a matter of this one did 10,000 mouse clicks and that one did 4,000 mouse clicks. Hey, you need 6,000 more mouse clicks. They have to be pedagogically actionable. So, the opportunity for real-time performance assessment, scaffolding, and alerting is here. It's here now because we have methodological advancements in computational techniques like data mining. And these offer an analytic leverage on students' learning processes, not just products. So they're done in real time, they're done at scale, and neither was available before. So also, computational techniques can handle the 4 V's of log data. So I think it's Draney who wrote about this first. But you have volume, the volume at which these log files, we're on dynamic AWS servers because, you know, the server load is extremely high. So you have the volume, they have the veracity of the log files, you have the velocity at which they're coming, and you have the variability in data. Because there's so many ways in which kids conduct inquiry productively and unproductively, which is why you need machine learning to score students' inquiry. You can't just use knowledge engineering. And these are transformative both for stealth assessment and real-time scaffolding, which is important to democratizing learning, right? And they offer scalability important to educational reform. So again, here's our system as it works. We're really excited about our alerts, and we're really excited about our tips. I'm going to tell you more about those things. But I'm going to show you, just break down what kids get. Kids get authentic inquiry with these simulations. Kids get a personal tutor named Rex, and kids get student reports that are aggregated at kind of a general level, because we don't want, especially those gifted and talented kids, to see that they went down like half a star and flip out, basically, right? Then we have components for teachers. We have these real-time reports and assessment reports, for example. So you have the dark blue are kids who are doing well. The light, these have changed a little bit in our new infrastructure, but the light blue are kids who are getting better as they're working. So you don't go and pull the kid up and say, what are you doing, right? You leave those kids be. They're getting better as they're working. Then you have kids in the yellow. These are kids who are at risk. These kids are not doing well. They're floundering, they're making unproductive errors, and you want to stop them in real time. And we've done experiments about when do you stop them, right? Because otherwise, if they collect all this confounded data, they get to the data interpretation phase, and they can't interpret their data because it's all confounded. Well, that's horrible, because now that's a lost learning opportunity, right? Nobody wants to, and it's very unmotivating to students. Oh, thanks, you just did all this work. Yeah, that data, just throw it out, start over. And then we have these real-time alerts that happen on teachers' phones, and I'll tell you more about that, because this is very cool. Teachers call us, send us gifts, send us letters. I mean, it's like a love affair. They love this thing. So this is what it looks like. So the teacher can use this in a variety of modes: individual student mode, whole class mode. They can decide what practice they want to focus on. They can set the parameters, tell me when even 5% of my kids are struggling. They can set all these things. So the teacher gets an alert here, John Marcone hypothesizing, and clicks on that alert. John is struggling to understand what an independent variable is. Well, if you don't understand what an independent variable is, you can't form a hypothesis, you can't collect data, you can't interpret data, you can't warrant claims, you can't do claim evidence reasoning. I say stop the kid. Don't let the kid do all those things, right? The teacher can walk over, gets this information about today's performance, gets all this contextual information. The teacher can look down and see how many kids are having trouble with hypothesizing, can switch to the class view and get an alert. 80% of my kids are struggling. I'm going to stop the class right now. Stop the class. Screens. Stop the class. And teachers literally call me and say, you won't believe what happened today. I stopped the class. We had this great conversation about interpreting data. It's really very, very cool. And then what we built were these tips, because what we found was some teachers were defaulting to content support. But if you give kids help about the content, first of all, that's not what NGSS is about. Second of all, it's not going to transfer. So if you give them, on force and motion, and then the kid moves to density, well, that's not going to help them. It has to be at the practice level. So we use epistemic network analysis to mine all the things that teachers said that led to transfer on the next inquiry activity on the practice they were helped. We wrote about this in Journal of Learning Analytics. It's Rachel Dickler, former graduate student, and Mike and myself. And then we mined those into tips, and we developed these tips. And teachers now can walk over and decide what tip to give the student. And it's at the actionable level. I'm going to talk a little bit more about that. So how do we do all this stuff? Well, we use machine learning under the hood for real-time assessment, scaffolding, and alerting. So we use data mining and text replay tagging to develop canonical models of what it means to demonstrate skill in a practice, and then develop our algorithms. And these handle the variability in student data. And we've done this for all inquiry practices now with a very close match to human scorers. Our algorithms are built on diverse student data and validated over multiple topics. And generalizability is tested on students who are not used to build the original training set. And that's classic, in computer science. So here's a summary. So you collect data, you build your text replay clips, you tag the clips for skills. Humans do this. then you build the features with rapid miner, and then you validate the detectors. And we actually got a few patents on this. So getting back, so now we're going to talk about, okay, so I told you a little bit more about the design, I told you a little bit more about how we do stuff under the hood. Now I'm going to do these fire hose studies. So the first is identifying the messy middle. Remember I talked about Billy and Johnny, right? So Billy's a science genius. He can do all this science, but he can't articulate what he knows in words. That kid, if the teacher's relying on a lab report, will be a false negative. Think about the frustration of this kid who can do all this stuff, and thanks for playing, you get a C or lower, right? When the kid knows all this science because the teacher's relying on their lab report or what they write. Think about John. John's not even doing the experiment. He's catching the buzz in the classroom. He's writing his lab report up. He's not even barely doing the experiment. He's being deemed as competent on all these practices because the claim evidence reasoning or the lab report is thought of as the culminating activity. Of course he knows all these things. No, this kid didn't even do the experiment. We have data exactly like this. This is going to be a false positive. This is a problem for the teacher. The teacher doesn't want to deem this kid as competent when they're not competent, right? Furthermore, this kid's going to get pushed along and along and along, and then what's going to happen, he's going to hit a wall, and he's going to hit a wall hard. And that ends his career in science right there, right? So I don't want the system to be used for teachers to go over and say, hey, who are you cheating off of? I don't want them to do that. I want them to say, hey, you know what? You've written a fairly sophisticated claim evidence reasoning statement. Now let's go back and pair that with a rich inquiry experiment so that you can understand exactly where these data came from. Okay, so let's think about here the doing and the writing, and Chris Quintana wrote a really nice paper about the sense making. So let's call the doing generating a research question, forming a hypothesis, collecting, analyzing, interpreting data, selecting data to warrant a claim. Let's talk about that as doing. Let's talk about the writing as the claim evidence reasoning, the communication piece, okay? And of course I cite Kate and Joe, and genuflect towards them for doing this. So here's a study in which we tested almost 300 kids in our density lab. And all actions data were stored in log files, and then we scored the sub-practices. And when things are operationalized at a fine-grained level, you can binatorize it and do it 0 versus 1. But it's operationalized very fine-grained, right? So, like John Anderson talks about this, that you have to be at a fine-grained level in order to binatorize it that way. Student CER explanations were extracted. We used rubrics that were developed and validated by my former postdoc, Haiying Lee. And then we scored these. We did inter-rater reliability. We had quite high kappas, 0.96, 97, and then 777, although we've changed that. And now we're auto-scoring CER based on NLP with very high correlations between humans and algorithms. So 0.90, 0.94, 0.86, respectively. So what we did, we used k-means clustering to answer this question about where students were in the Billy Johnny, in the doing versus writing, right? So you see here the false positives, the low on doing, the high on writing, the kid who's only parroting what they've read or heard. We've known about these kinds of kids forever, right? You have a lot of kids there. But where I think we've not done a service is these kids at the other side, these kids, these Billies, right? The high on doing, low on writing. Those kids also exist. We're throwing those kids away. Those are our future scientists and engineers. We're tossing them away because they're getting pushed out of high-level science because they don't communicate well in words. So here's some examples. These are real data. The name is just changed, okay? So he ran a successful investigation to analyze the data correctly, but didn't know what to write. He wrote, I already did this part. The answer to this is in my claim, I think. Reasoning, I don't know. So if the teacher's relying on this kid who did everything correct up to this point is going to get a big fat 0, right? So that's problematic for a few reasons, because that's a false negative, but also the performance expectation of NGSS expects kids to develop these communication competencies because they're important, because we communicate in words, because science is an endeavor where we communicate in words. So that's the other reason. So our algorithms, by the way, are quite stringent, and some teachers were like, ooh, I would have given them a higher score on this. And then we've loosened them up a little bit, but we say, you know what? If you want your student to get a slightly higher grade, when you import your grades from Inkits, just give them a couple extra marks for this ER. It doesn't offend me. All right, here's Johnny. Johnny's our false positives. Real data. He wrote about an experiment that he did not conduct. Okay, so he's writing about the shape of the container is the shape of the container the liquid is in does not affect the overall density of the liquid. He's right about that. He didn't even run that. Look, container shape, narrow, narrow, narrow. He didn't change it. He's changing the liquid type, but he's catching the buzz in the classroom. So he writes that. If the teacher relies on that, the kid is going to be deemed competent. He didn't even have the data, right? Again, he talks about here wide to square. He didn't change wide to wide, 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 right? So he's learning something, but he's not learning what we think he's learning. Here's another example. He writes about the density, but in fact, it's not accurate. He's actually getting this from somewhere else. So when you have this fine-grained data, you can also decide automatically who to scaffold. So there's only one quadrant that doesn't need scaffolding, and that's the high-high quadrant. But there's not that many kids, right, in the high-high quadrant. All these kids need scaffolding. So we can jump in real time, and that's what we do, if the teacher chooses to run with reps. So in our discussion of this, our findings demonstrate that the messy middle exists in inquiry performance and can result in false negatives and false positives. So we've replicated this a number of times, and this is a statement about evidence that we need to assess the full range of competencies, and they need to be assessed at a fine-grained level, because otherwise there's lots of information about the student's strengths or weaknesses that you're missing out on. And teachers will say to us, oh, I knew this student knew a lot more than I could ever get out of them on an assessment. And now I have Inkits and I can see where they're doing really well and where they're not. Or here's a student in special education who I know exactly what they're getting better at. And if they're using Title I or whatever, they have to report out on how the system they bought has improved students' outcomes. So teachers use it in that way. So I want to tell you quickly about scaffolding, and then I want to get to ink blotter a little more, because that I think is most exciting. So, you know, we've operationalized the practices at a fine-grained level. Rex is operating at that level, and so we wanted, the NSF required us to do a study where we measured the efficacy of Rex. Okay. So what we did was we took 107 kids, 6th graders, completed 4 inquiry labs, animal cell with Rex, okay? We dropped Rex out. 40 days later, no Inkits in the interim. They did plant cell. Those are very analogous in difficulty level. Another 40 days later, we did genetics. Certainly harder than plant cell or animal cell. Another 90 days later, we did natural selection. No Inkits in between. And I don't think kids are going on at home and getting onto Inkits. They have other interests. So we used our lab, this is an example, right? And they received, again, scaffolding only in animal cell. So we gave these kinds of scaffolds when kids failed, or when they were having difficulties. We jumped in with these kinds of scaffolds. And these come out of things like the Intelligent Tutoring System community. And we measured everything using our knowledge engineered and machine learned algorithms. And again, we jumped in and we compared the performances using repeated measures ANOVAs. And what you see here is a significant interaction between time and inquiry practice, and also statistically significant for the within subjects effects. So at time 1, you see the different practices, right? Green, blue, purple, and red. Time 1, they performed at a certain level. Time 2, they actually got better. They got better at time 2. So they really learned something that they applied from time 1. 40 days later, we dropped out Rex after T1. T2, again, no Rex. T3, they had genetics. Genetics is inherently harder to experiment in versus animal cell or plant cell. And you see a slight degradation in the performances, in particular the data interpretation and warranting claims. It's more difficult. You see a slight degradation. Then 90 days later, we went back And we did evolution, again, a more difficult topic, and all the performances came up again. We taught these kids something. They learned something, right? And our claim is if you can teach kids how to form hypotheses, collect data, interpret data, warrant claims, and do claim evidence reasoning, you will have taught them something very significant that will take them far in STEM. So the bottom line here is that you can scaffold at this fine-grained level, and it really supports robust learning and robust transfer. Now I want to run to talk about Ink Blotter, our dashboard. And again, we're just really, really excited about this. But there's a lot of dashboards out there, well, a handful for science, but they're very coarse-grained. They're multiple choice dashboards. They're very coarse-grained. They're not well suited to NGSS. They're all really content, to be honest with you. And that's, that's not useless. It's not particularly useful if you think about it in terms of what NGSS's vision is. But few don't have the capacity to fully assess the inquiry capacities. And by few, we actually mean none. So INKITS then provides these fine-grained alerts and tips based on our AI-based assessments, right, that is important for actionable support to students in real time, right? And teachers need formative data to inform instruction. So we have learning scientists like Lair, Schabel, Berlin, McNeil, Gottwells, and Anderson. They need it, and they need it on the fly. Like, you can't say, oh, last week when you were collecting data, by the way. Kids will be like, what do you mean? That would be like a tennis instructor saying, oh, last week when you did that, like, don't do that. Of course, that's not useful, right? You need it in real time. And they need guidance on how to use these formative assessments, right? And they need information and data at the right grain size. And that's what I'm arguing about. It's the grain size. So I'm not specifying learning progressions as like, what do you call it, an alert about my chapter for you. It's not about learning progressions, because I think that learning progressions presuppose a theory of mind, and I don't really think that students necessarily have theories of mind around science. It's not that they couldn't, it's just generally that they don't. And certainly instruction doesn't always support those theories of mind. So teachers need this information at the right grain size. So what I'm talking about are sort of like your learning performances that you wrote about with Christopher Harris, but they're at a finer grained level, like the IV, because if kids don't understand what an independent variable is, they're done in the water, right? It sounds trivial until you think about the role of the independent variable. Okay, so we're going to get back to this. So you have these alerts, and then you have all these things. Like this thing is instrumented. This is like a Tesla, right? Like this thing has anything, a slow progress alert. If the student's spending too much time on one phase, the teacher is alerted, and that setting can be adjusted by the teacher. The teacher has actionable data on that student, but this is where I think AI is really useful. Do the things that are onerous for teachers, and then let them use the data in ways that are useful for them. So a slow progress alert, there could be a whole bunch of reasons why kids are proceeding slowly, and Michael and I had a great conversation at breakfast about this. Like their parents might have split up, you don't know. So, but the teacher has this data and can walk over and say, hey, Wendy, is everything okay today, right? And that's what I love about this. And teachers are making these really rich inferences about their students based on the data we're giving them, and walking over and going, this is kind of atypical. Let me walk over and check out what's going on with that kid. So we have all these class-wide alerts. So see here, there's 50% of your kids are struggling with collecting data. So the teacher can stop the class. So it's very useful for teachers, and they're extremely flexible with how they use this. So what we wanted to do, and we had NSF funded us in cyber learning for this, is to ask, are real-time alerts for inquiry practices associated with student improvement? So think about your logic model. If teachers' help is not helping students, why would you provide them that help? Furthermore, if you know what helps students, why would you not provide them that help, right? And does the pattern of teacher support provided to students differ in relation to performances on practices? Again, which practices seem like they're movable, and which practices do we really need to drill down on? So we tested this with 211 kids, 2 middle school teachers, and they did 3 inquiry labs. We did audio data of the interactions, so the teacher walked over with an iPad, hit record, and then our software engineer had written this piece that bundles it all together, the teacher data, the student data, and all the voice data. It's just super great for research, right? And we scored our students' competencies. We took log data from Blotter, the alerts that appeared for the teacher, the student alerts accessed by the teacher, the content of the alerts, all the timestamps, so you have this. And then we culled 35 recordings that were captured, transcribed these, and then scored them for science practices versus things like content support, right? And we wrote about this in Journal Learning Analytics. So we asked, are real-time alerts for inquiry practices associated with student improvement? So we triangulated these, we used MANOVAs, help versus no help. And you know what we see is that students' help based on alert had a marginally significant greater improvement across activities on the practice on which they were helped. So teachers' help is helping, and you see that, the dashboard help versus no help. And you know, this is pretty impressive because this is just 3 driving questions. And learning inquiry is tough, but we are moving the needle for students. And does the pattern of teacher support provided to students differ in relationship to the pattern, to the performance on practices? So again, we compared when students' help improved or when it did not improve on their next activity using epistemic network analysis. So here what you see is students who did not improve received combinations of lower level and content supports more frequently versus kids who improved. So don't give content support because guess what? It doesn't transfer. And NGSS is not about content. But here you have in a logic model a nice way to measure these things. So these findings have important implications for designing alerts to promote explicit practice. So not surprisingly, what did we do? We mined those data. We looked at what led to transfer on the next inquiry practice, and we pulled them in and developed these tips. So I'll just tell you about these. So we took like 219 segments and we mined them, yada yada. And now you can press for tips, and teachers love this because if they don't know what to do, they need a conversation starter. So here's orienting support, conceptual support, procedural support, and instrumental support. And we're working very closely with teachers to see what they naturally do. So I say in the absence of not knowing, just follow this progression. But if you have insight into the individual student and you want to help them differentially, do it. So we work with Angela Marksbury, who was Science Teacher of the Year in Kentucky a couple years ago. And she did something so creative, and I love this because our teachers are so incredible with how they use the data we give them. So what she says is, if I have a high flyer and they're having trouble, I go to the conceptual support because it's kind of the most high level, like, gee, how will you know about the effects of X and Y given your data? Because you just want to put down that little breadcrumb and have the kid generate the strategy that they need to target their independent variable, keep the rest the same, right? So she's like, I'm going to use that tip first. But with a kid, if I know the kid's frustrating, I see them moving around in their chair, they're taking a lot of time, I'm going to give them the instrumental or the procedural support. But I'm not just going to give it to them like a cookbook. I'm going to give it to them, I'm going to watch them do it, and I'm going to say, now, how is this different from what you did? And how will your data be different and allow you to address your question? And that's what gets reified in long-term memory, because the student is saying to the teacher, this is what I did, and this is very different. I targeted my independent variable, I kept the rest the same, and then I ran successive trials. So I'm going to close there, and rather than run you through this study, because I do want to talk about formative assessment with you, but all this to say, we used evidence-centered design to build this system, and this is really the future, I think, of assessment, is performance assessment, and I think this is that we've threaded the needle in a really good way for students to learn, and we have evidence of transfer, so I think that means that we've threaded the needle at the right level of specificity, and for teachers as well, to actually realize NGSS in their pedagogical practices and real-time instruction of NGSS. So in closing, this is my team. on the Rutgers side, and this is our team on the Apprentice side. So thank you so much, and thank you to the NSF and the U.S. Department of Education. It's been very generous to this project. Thanks.
I know you have to leave because it's 1 o'clock, but if you have questions, as I said, Janice is more than willing to hang out till 1:30 and respond to questions. So Jonathan, go ahead.
I'm wondering how you can apply this. I know you're starting to do this a little bit with PISA, but how would you apply this to high-stakes state assessments? Because I think that a lot of states, and I can speak a little bit for Michigan, are not using a lot of AI-based assessments. So how can we move in this direction?
Well, I think you could do a really nice performance assessment, and rather than ask multiple choice questions, you ask something like this, and you make it in a content area that students have not addressed, for example. You could do one within a content area, you could do one outside a content area, and see how far they get. And that's really so you could use the portion that's within the content area, say for 8th grade, if physical science seems to be the target, right? You could have one in physical science where you make up a hypothetical world, for example, right? So they're not applying content knowledge per se, they're applying what they learned in inquiry to this new planet or something like that, right? We have an activity like that in our system. And then you could do something very domain general too. So say kids are maybe worried about, oh gee, I don't really understand the physics, I didn't really know in class. Make it very domain general, like candy, sugar in a chocolate bar, red dye in a water, in a vase for flowers. We have an activity like that gets at kids' inquiry skills in a domain agnostic way, because a lot of kids they see acceleration and all of a sudden they go, oh, I don't know anything about acceleration. Affective filter goes up and all of a sudden they don't perform well. So we have teachers who use those baseline data to build their competencies at inquiry and get them used to the system. So you could use something similar to that in a performance assessment. You could also see how much help they need, right? Like, do they need 4 hints? Do they need 2 hints? Is 1 hint enough, right? As a measure of their competency. Yeah.
Can you give some examples how do you assess your level of implementation without writing? Like what students do during the simulations that allows you to assess their level of
Oh, okay. No, they are writing. They are writing. We're using NLP. And what we've done is we've operationalized the claim, the evidence, and the reasoning. So, for example, we borrowed from work like that has been done by Kate and yourself and Bill Sandoval on, are the data sufficient? Are the data appropriate for the evidence piece? So we operationalize it that way, and then we score that using NLP. So in the evidence portion, our algorithms pick that up, and then the student gets a score for, are the data that they've chosen sufficient? Are the data that they've chosen appropriate? And we auto-score for that using our NLP. And so then we have a unique measure of claim, of evidence, of reasoning at a subcomponent level. There's levels and levels and levels beneath all of these things, but we aggregate up to the sub-practice. And then we report out. So then the teacher can say to the student, walk over and say, hey, you wrote about trials, but not all of them are unconfounded trials. Revise your explanation so that you're only writing about the trials that you're targeting your independent variable and that you've changed your independent variable and kept the rest the same. That's what an evidence statement is. Or if a lot of kids are having problems with evidence statements, as many kids do, although reasoning is the most difficult part, is the teacher can put up some data and say, hey, let's, as a class, talk about what you would put in as evidence, given this evidence. All right, our evidence needs to be sufficient, and our evidence needs to be appropriate. Now, here's the data set. What are the appropriate data that we should select, and is that sufficient to warrant your claim? And then, we report out to teachers. They can look, and they can get very fine-grained data on where students are doing well and where students are doing poorly, and give individual support, pull them into breakout groups. During COVID, again, I mean, teachers were amazing at what they would do. They were using our stuff on Zoom, and they were pulling them into individual rooms. We didn't tell them to do this. They had a question formation room. They had a data collection room. They had a data interpretation room. And they would just pull kids in. And they would say to the data interpretation kids, like, you try to help each other. I'm going to the hypothesizing room for now, right? And help these kids and get them on their way. Go to the data collection room, help those kids. If you have a co-teacher, we have co-teacher functionality. So a co-teacher could be helping, jumping in. So in special education, the paraprofessional or co-teacher or a substitute teacher, because a lot of teachers are out with COVID, they can get these data and help the kids in the classroom. So we really built the system so that it's end-to-end formative assessment and real-time support for NGSS. Yes?
So I know you said your system focuses on inquiry, right?
Right?
But often students' disciplinary ideas intersects with that. The
Right.
example you just gave is perfect, right?
Right?
So you can't select appropriate data unless you understand what the appropriate data is.
Right?
So that seems to focus more on the disciplinary areas. So I was just curious, how come you don't blend that in? So for instance, in some of our work, the kids, particularly when you're talking at the middle school level, and you're asking them to identify a substance, right? So they're going through and they're trying to figure out what substances they're saying. Often, you put mass in there as a distractor. So the kids will select mass and density and temperature, and they'll say A and B are the same because they have the same mass, same.
Yeah, I saw that
right?
activity. Yeah.
Right. So I'm just curious, if you don't support them in understanding that mass is not a characteristic property, then they can't select the appropriate data.
Well, but if we had mass in our, which we do, we have distractor variables, and some that seem relevant and that are not relevant, right? Like shape of the container. And the student is collecting data about shape in the container, but they've hypothesized about, type of liquid. Rex would jump in, but that's a slightly different issue, right? So each driving question is oriented toward the thing we want them to experiment about, right? So that's how the disciplinary core idea is folded in. So they're doing inquiry on the disciplinary core idea. And first teachers said, well, we want multiple choice questions because how will we know about the content? How will we know? And I said, okay, so we built a whole bunch of them. We built a whole bunch of them. And now that they have them, and they're well attuned to inputs, they never use the multiple choice question or rarely look at them. They look at the kids' contextualized understanding about the DCI in the context of our inquiry experiment because they align to the performance expectations. So, and then what we do for the cross-cutting concepts is we have in Help Scout, the teacher can write in the performance expectation, the number, and then up pops all the units that deal with that. And so if the teacher wants to see how they got better on thus and such cross-cutting concept, they can pull those up, pull up that assessment report for those activities and go, wow, they got better on this cross-cutting concept over time, right? Because there's not a cross-cutting concept well, there's cause and effect, but it's science. There's cause and effect in all science, right?
That's right.
It's types of cause and effect that are important.
Yeah, go ahead.
This is an excellent talk, by the way. I really
Oh,
enjoyed
thank
it.
you.
I'm curious about Rex and the feedback there, especially because I'm assuming the setup is, if students are having trouble with something, Rex jumps in, and then if they continue to have trouble, that's when the teacher's alerted. Is that?
No, the teacher's alerted right away, but what's really beautiful about this is that when you're in middle school and high school, you do not want to be the kid the teacher's always going over to, right?
Right.
So other kids don't know that Rex is jumping in
So Rex jumps in and
proactively.
when does the teacher know to go to that student?
So the teacher can set the alert for sensitivity. So, alert me when, 40% of my classes, alert me as soon as anybody's struggling, and then look at that student. If she's gone over to that student a lot of times, she might decide, this kid is really sensitive to knowing that other students are, going to know that they're getting help.
Yeah.
So she can hold back, right? She can hold back and not go over and just let Rex get him,
Yeah.
right? So that's really useful because middle schoolers and high schoolers don't want the teacher constantly going over.
Right.
We had kids, it's interesting topic, this topic of conversation. during COVID, we had a lot of kids, including kids in, schools with high proportions of ELLs, of minorities, of kids on free and assisted lunch, did better at home with INKITs and RECs than they did in the classroom.
But they didn't have INKITs and RECs.
They had INKITs in the classroom.
Really?
But what's interesting about it is they were just more motivated when they were on their own, maybe because they were less worried that kids knew they were getting help. So one teacher, her name's Cheryl Chu, she works in Compton. We do some work in Compton, and Compton, LA. And she was like, wow, what's the sauce here? Because we have these kids that I couldn't get them for love or money, and they are in, they're motivated, they're doing well. The same thing in Arizona. We have a teacher who, COVID hit, kids weren't coming to class virtually, they weren't doing anything, but they were showing up to do INKITs. At NSTA a couple years ago, this was pre-COVID, and we had just launched our alerting dashboard, and this teacher came up and she's like, I have a bone to pick with you. And I said, really? And I always want to know, right? We say to teachers, if there's something you don't like, please tell us. And she goes, well, I'm in hot water with the math teacher. And I said, well, why? And she said, because they're in my class and they're doing science and they're supposed to log out. And they go to math class and they log back in, and I know it because they're showing up on my alerting dashboard. Now the math teacher is like, hey, get the kids off INKITs. And it's not that teacher's fault, right? The kids are going and they want to finish their science homework. So it's kind of cool, right? So the thing that I love about kids is in our environment, because I'm not a big fan of gamification, and I think that if you're wanting to engender critical thinking and higher level epistemological frames for science, you can't pay them in digital bananas. Like, you don't get there from here, right? So there's nothing like that. And when there's a gamified version of INKITs, it's because you should look for my obit, because I've died. Like, it's just not ever going to happen, right? It's being recorded for posterity right now. But we asked kids, like, what do you think about your teacher having all this fine-grained data about you? It's because it's a little bit, we know what they're doing. We're in their head, We surveyed like 300 kids, and they said, I don't necessarily like it, but I know it's important for my learning.
Do you have to get IRB from
Yes. And I mean, I will take that any day, right? Because the sooner we get back to school is a place where you go to learn things, I think, the better off we'll be. And this is maybe like kids who are, in Compton going home and getting really involved in their science. Maybe they're like, wow, I know that this is the path for a future STEM job for me. Who knows, right? But that's always very exciting to me when kids go, wow, this is really helping me. This is really going to help me. And I think they inherently want to do well. I do think that about people. Maybe I'm a little optimistic, but I think kids want to do well. Nobody wants to fail at something, right? Even if they don't love it, they want to do well. And so we're really happy about that part of our system, having moved the needle for students and having teachers just go, wow, this saves me so much grading time, gives me the data I need to help kids at the right level of specificity. One teacher's like, this is like a crystal ball. Like, I can walk over. We did an empirical study where all we did was we had the names for some teachers on an alerting dashboard, and then we had the alerts and names on another, and we showed that twice as many kids are helped rather than like just the names, and maybe it's even like an alert. Twice as many are helped, given much more targeted help, and that targeted help leads to transfer of the practices. So that in and of itself is really useful for teachers, because otherwise and we had to do iterations of this dashboard. Believe me, it's not like, we dreamed this up and then the next day it was up and running this way. Like, teachers were getting alerts like, oh my God, I didn't know so many kids were struggling. Like, what the hell? What am I supposed to do now? Right? It's like ping, 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 ping. So we had to change the features. We had to say, okay, when do you want to be alerted? Do you want to be in whole class mode? And then we had to work very closely with teachers, interviewing them and seeing what they needed. Because a lot of teachers were like, oh my God, all of a sudden now, I got 40 kids in my class and 35 of them need help. You know, now I'm really losing sleep. What do I do now? I was happier when I didn't know, right? But it gives them the data they need. Like, so another teacher, she said, well, I always thought kids had trouble with data interpretation, but I realized many of them had confounded data. They can't interpret data that's confounded. Now I know who's having trouble with data collection. Data interpretation too, but first you have to collect unconfounded data, otherwise you can't interpret it, right? And she's like, I taught for 29 years, I didn't know that. I always thought they were having trouble interpreting data. They're having trouble collecting data, right? And she's trained as a chemist, initially as a scientist, so it didn't occur to her that the kids were having that trouble until she used our system. So,
Let's take one more question.
There's one question online, and this was asked roughly between your talk. What are your thoughts about the product's adaptability and suitability for large, lower-level undergraduate STEM courses?
well, that's a good question, because I think, you know, a lot of these science misconceptions don't change much between middle school and high school, and some carry forward into university, right, into college. So if you're thinking about, you know, making sure that everybody's kind of at the same baseline of knowledge and skill, you could use eKits for that. Certainly, I mean, we have teachers who told us, like, we've learned a lot of content from your modules. We learned a lot, and that's great, right? I'm happy about that. And the mathematizing practice is interesting because some teachers are saying, I haven't done this math since college. How can I integrate this into instruction? So we're developing these teacher resources that are say, okay, these are the kinds of mathematics that is involved in these science labs, and here's a little primer, and this is what you're going to get. You're going to get assessments of this. And you know, then it comes back to them, right, because they've studied it before. But yes, so we have had colleges think about that. Votex especially, people want to get into a career, but they're lacking certain science courses, using eKits for that.
All right, let's give Janice a big clap.
Oh, thank you so much.
Give her a traditional gift and card.
Really? Oh, that's so nice, Joe. What's in this?
You have to open it up.
I was going to say, is it one of those Create mugs?
No, I still ran out of, but it blows up actually, it's, you know, because
Oh, really?
it's a nice mug.
Oh, does it? Is it one of those sweaters? I was looking at Bob's sweater. It's like, oh, it's one of those Create.
Yeah, we're.
I can read it, thank you. All right, I'm curious about it. It's a paperweight, what is it? Oh, thank you. Oh, great, thank you so much. Yeah.
We have this almost like.
Oh, that's perfect. In fact, I can charge that up. Thank you all, thanks for coming.
Thank you.
Thank you very much. So now you can like, couple of minutes, go to the bathroom, relax, and then you do the other thing.
Yeah, so this, I don't know, how do we turn this on? Great, thank you. Well, good, I wanted to, you know, sort of push on the formative assessment part, because I felt like that was, based on what I read, you know, of interest. Hey, how are you?
How are you?
I'm good.
I love your red picture.
Oh, thank you. Yes. Well, we have glossaries, Spanish glossaries. We have some baseline activities in Spanish, and we have some in Chinese too. Yeah. Well, the kid can pull out the glossary in real time, you know, using the density lab, like what are the terms, and get so they get the translation of, you know, hypothesis, of, you know, density of the various terms, so that they know what the system is asking, right?
But your calculation accent from your system, using the data system, right? Why real-time data, how is the system can take that part?
Well, the system doesn't, but we do in our data, in our data analysis. Yeah, we can do that. you know, for the research, right? And the teachers know, so when they get, if they have an ELL, they can accommodate in certain ways with their grading. So they pull the grades down and then they can adjust them if they want. Because sometimes the IRB doesn't allow you to get that information, right? Yeah.
Keep it quick, you know, no one can know.
Yeah, yeah.
Yeah, because I really love the way you describe it. I couldn't find in my classes, you say, the whole class lessons as the person is writing.
Right.
Assessment, people's different way to show.
Oh, yeah.
performance part.
Right.
If you put this concept into the AI best,
Right,
and how it can help.
right, yeah.
But I really.
Oh, thank you. Thank you so much.
Can I just close off
Yes.
on Zoom?
Yeah, absolutely.
Anyway, thank you, I enjoyed that.
Oh, good.
It's nice talk.
Oh, thanks, thanks. Oh, I see. Okay, I don't know how many people we had.
We had about 2 to 4 hours enough.
2 to 4 people?
Yeah.
And then the room.
Yes.
Okay. That's not very many, but that's all right.
You mean online?
Online, 2 to 4 people.
Yeah.
Thank you for this, Joe. Very nice of you.
Thank you for coming.
Yeah, no, it's great.
I think we had about 20 people here.
Yeah,
Usually we get between 20 and 30.
right. So do you do every week? Every other?
Typically about once, we try to do like 4 a semester.
Okay, once
So
a month
the
about?
next person who's at the end of this month will be our last one.
I think once a month is about good. I mean, Ravita is running ours now, and it's once a week, and I think we really struggle to get attendance and really
Yeah,
struggle
it's too
to.
much. We
Once a
cancel-
week is a lot, and then, you know, people said, well, if we do every other week, people aren't gonna put it in their schedule, but I don't think it's that hard.
Right. So we sometimes have, instead of a guest speaker, we'll have someone present research that they're doing.
Oh, right, that's,
Someone
yeah,
from-
that's what Rutgers
Someone
does
from
too.
here.
Yeah,
But, you know, we try to do something 3 to 4 times a semester. But then at the end of the second semester, we typically, actually, this was what you were gonna do last time. We have like a road mini conference. And that's nice. People submit posters, and we have a luncheon and a
oh, nice.
keynote speaker.
Oh, yeah. Do you ever have Marcia? Did Marcia ever come?
I know, you know, it's interesting. I should invite Marcia. I never thought of it.
Right, yeah. Or Nancy, well, Nancy's a dean now, right?
Yeah.
How's she liking it, do you know, or?
I think she likes it, you know. But one time when I first asked Nancy when she went to the dean at Penn, was she
Oh.
dean at Penn?
Oh, Drexel.
Drexel. She said, I really like it because I'm in charge of people and I don't have to worry about being it because that's my job now. So,
Well, I could see she would be great in that role.
Yeah.
Yeah.
I don't know why she moved to Utah.
Yeah. Well,
I don't even think Drexel's a big university. I don't quite.
yeah, unless
Maybe she
maybe,
wanted a big state university.
or wanted to be at a, you know,
It's a bigger-
she skis, right?
She does ski, that's
Yeah,
correct.
but is that enough motivation? It wouldn't be enough to draw me, but
No, you can always take a plane to ski.
that's right, you can always go skiing, no problem there. Go skiing.
So, you know, I'm now, Nate this year, they're rewriting the framework, right?
Oh, yeah,
And there's the steering committee, and there's the development committee, and there's this leadership group,
right,
and I'm on all 3.
okay.
And so,
That's what I do my reading for.
what do you need?
My reading though.
Your reading class.
Oh my God, without.
They're different from the ones you have on.
Yeah, this is kind of like.
Anyways, so I'm this, so before in the past, they always had like one person in charge of the thing.
Yeah,
And now they have this leadership. Anyways, so I'm on that, there's 4 of us. And I know they want to invite speakers in,
okay.
but they're against NGSS.
Oh, really?
Right, because, you know, 5 states don't do NGSS. So, in any form, right? So they're sensitive to that.
Okay,
So if I get you to come and talk to the group, you can change, you just substitute NGSS or framework.
Yeah,
They're okay with the framework.
okay,
They're against the NGSS.
yeah, absolutely. I mean, and we sell stuff to, let me grab myself something here. We sell stuff to, states that are not NGSS. Oh, thank you.
know, DS19, 2019,
You
your
need
passport.
that?
It's in my email, so just read my email and, yeah, it's about 10 days ago I sent it to you. It was not last week, but previous week. Because we don't have a lot of time left until January 1st.
I'm sorry, I missed
I figure you probably didn't notice it, but we need to get that done as soon as possible.
that. I'll be in the office on Tuesday,
Next week?
yes.
Okay, I'll make sure I'm here. You can look later, I know you had a meeting, it's not an emergency, but yeah, just make sure you find it.